this. So yeah, now we're going. So fragmentation, that breaking up of the habitat happens in a predictable fashion across the landscape, and we can basically understand how it occurs because it's been going on for hundreds and hundreds of years as humans basically have been growing in population, colonizing new spaces, advancing technology and allowing better use of resources or more efficient use of resources, needing more resources as populations grow. So we can look even to, England is a great example, looking at forests in England through time. And what you had was, your main population centers in 400 there, you can see we're connected. And that's kind of where agriculture was happening. Populations grew, they expand into the areas that were not really habitated before, that were mainly forest. You start taking out that forest, converting it to another habitat type. And then that continues to advance to where we're losing more and more forest through time to kind of where we're at now, where there's basically no major blocks of forest left in the landscape. Now, this trend happened over hundreds and hundreds of years. In modern times here, we look back in the last 50 years, we can see that pace due to the efficiency of technology, the growing population, everything else, that can happen in a much quicker rate. As we look at Borneo, which from 1950 was mainly forested and now has lost about 60 to 70% of its forest in a very similar fashion, right? So you can see there's points of entry into the forest, and those expand. So the big thing to think about in terms of wildlife and why fragmentation is important is generally you have a loss of what we call interior habitat. So that's that main block of habitat inside the larger block that is protected from edge species. It has different characteristics climatically than the edge. And there's other impacts of edge on species production and so on. The other thing that you need to keep in mind is as fragmentation occurs and advances, you get a decrease in connectivity among those habitat patches. So it's harder for animals to get from one area to another because usually the patches are smaller, the distance expands between patches, and there's not generally a whole lot of corridors available to them. And corridors we're going to talk about here in this lecture. So there's multiple different degrees of fragmentation that are pretty identifiable as it occurs, and from start to finish, you can see these go through time as an area becomes more fragmented. So it basically starts off with dissection, where usually a road or a railroad or some form of travel corridor goes in for humans that allows access to resources. That road goes in, breaks up the area, and resources start to be taken out, like forests, or begin to be transformed from forests or grasslands into agriculture. So that's called dissection. Perforation is the advancement of that to basically increase the access, maybe even further into the forest block, or increase the amount of resources being taken out. Then we reach an actual stage, what we would call fragmentation, where there's basically just patches left in the landscape, maybe a few corridors, which would be the bottom right picture here. But the vast majority of what the original habitat type that was present is now gone and replaced by something else. And finally, we get to the attrition stage, where there's mainly just a few blocks of what was the original habitat remaining in the area. Now, what does this kind of look like in real life? Not just colors. So you see this main forest block up top, and initially a road gets put in. That road is the dissection point where the forest basically is cut off and allows access to resources. That advances, generally humans move into that, use that road, and then start extracting resources or converting those resources along the way. Usually what we'd see are things like homesteads or small farms taking over and clearing going around those homesteads. They would be very much closely related to the road itself that was put in. Moving along, when you get to fragmentation, usually you see more roads being put in and more extraction of resources, potentially increasing human population, right? Finally, to the attrition stage, where basically complete conversion, you may have few remnant patches left, and maybe higher population or just a different resource use occurring that was converted, something like agriculture. All right. Now, why does this matter? Well, it may or may not matter depending on the species you're talking about. A lot of that has to do with how species are viewing the landscape and navigating the landscape. Sometimes, just the conversion of habitat to a different type, is not necessarily a bad thing, right? So we talk about disturbance and going from a mature forest to a young forest, or a forest to a grassland. It's still, good habitat in many ways for wildlife species. However, it's just, a different type of habitat. So some species are winners and some are losers. But when we're talking about fragmentation and patches that are remaining, depending on the species you're managing for, there can be different impacts on that species. So some species are going to perceive and use the landscape at small scales. For example, you're looking at a sparrow on the left there, which is really using landscape and perceiving landscape at a couple hectares at a time. However, things like kestrels or larger space use species, what they see is very different. They see a bunch of patches on a landscape, and they have to navigate those to survive, find food, and so on. So how fragmentation can impact these species, generally the larger species are more or larger space use species are more impacted than the smaller space use species. And that has a lot to do with this concept of the matrix. So I'm not going to make any movie jokes here, but what really the matrix really is the areas that are outside of what we would call the animal's normal habitat. So this could be the fragmented space. So what was replaced? And the overall viewpoint of the matrix and everything and how the animal navigates the matrix depends on a couple different things. So you're looking at the porosity, so the density of patches that are remaining, the shape of those patches, how much edge there may be, the heterogeneity, the degree to which those patches are there in the matrix. So how many are there? And then the network, which is basically how connected are those patches with corridors. And a corridor is basically just as it sounds, right? So it's a smaller connection. It may be good habitat, it may be poor habitat, but provide enough cover for the species to make it from one good patch to another. Or there could be no corridors and the animal has to navigate the matrix that's there, which there are different levels of how harsh a matrix is to a species, and understanding what that matrix type or poor habitat does to the species is really important in understanding the potential for connection between patches. So for example, if you look at the forest here, the picture in Brazil, you can see that there are these ridge tops with trees that are running between patches. And that is probably just enough of a corridor to allow many species to navigate what is now agriculture and make it from one larger forest patch to another. However, if you look at the distance for the close part of the picture to the far end, where you get to another larger forest block, that distance, no matter how the presence absence of a corridor, if it's a long way to get to another good habitat patch, it's dangerous for that species to navigate it. And so the smaller the distance between patches, the more likely the species is to succeed when moving between them. All right. So the definition of a patch here, I keep using it, but reality being the definition is basically a nonlinear surface area that differs in appearance from its surroundings. So in essence, what we would call a patch is it could be a good quality habitat for a species that we're managing, that is very different from what's outside it. So if you think forests, then everything that's not forest is not part of the patch. But you may have small pockets of forest that are in the matrix that exist, and those would then, be called patches. Now, there's two concepts I mentioned: interior and edge. So all patches are made of interior habitat and edge habitat. Edge is what is basically butting up next to the matrix. You have different characteristics. We talked about edge feathering in last class, where you get, basically you have slightly different resources available immediately upon that edge. They get more light. There's access to there's different temperatures. There's different wind levels that hit them. So you get slightly different species. So the interior forest, so basically where that effect stops, is what we call an interior forest or an interior habitat patch. And that's generally more traditionally what the habitat would be considered. So you get a little bit higher quality forest or higher quality grassland. The larger the patch, generally, the more of that interior habitat is present. And the shape of the patch matters. So and we're going to talk a little bit more about shape later, but how irregular that shape is, can create more edge habitat. Generally, if it's more circular with less edge, then you have more interior habitat. So here's the definition of corridor. I've used it a couple times already. And basically what it is it's a narrow strip that differs from the matrix on either side that has some level of value to that species that would use it. It may have cover, it may have some food, but more importantly, it has cover for them to use as they move from one patch to another. So it can be things like, and commonly is things like riparian areas, ditches that were not able to be converted to agriculture, wind, sometimes there's hedgerows, those kind of things. All of those are common corridors we see in the landscape. And all of that is important because usually when you have a loss of habitat, heavy matrix load present, a lot of patches or maybe a few patches, what you're actually managing is not a continuous population. What you're managing is a metapopulation. We briefly talked about this in a previous lecture, but what a metapopulation is basically a network of connected small populations of the same species that have some connectivity where there's individuals moving back and forth between them. So we would call them semi-isolated with intermittent migration, so intermittent dispersal and immigration. Okay, so to be a metapopulation, though, you have to have gene flow present within those small patches. And usually what it is there's some good habitat patches that have animals present in it. There may be some good habitat patches that don't. And as animals move through the landscape and navigate that matrix, they colonize and are potentially extirpated from some of those patches. So there's a couple different types of these metapopulations that you should be aware of. So you have what's called the classic metapopulation, where you have certain patches are present and have populations in them. Some patches do not, but there's movement between them on a regular basis. Okay, and they kind of blink in and out. Hold on, guys. I'm gonna need to take a break here for a minute. I'll be right back. Okay, I'm back. I'm sorry. So that the Levens population, Levens was actually the original founder of this concept. And he noticed it in several small mammals and other species. Um, the next type is the mainland island metapopulation, where you have a basically a larger patch that's the source population, and animals regularly disperse from that to smaller patches that are present outside of that big patch. And in those smaller patches, those little subpopulations may survive for a period of time and blink out. Some patches may, then not be colonized for a period of time before a new individual finds it. But that main larger patch doesn't generally lose the population. It's kind of the source, but there's always animals present within it. Now, there's the non-equilibrium metapopulation, where you have some animals or some patches that have species in it, but movement from those patches is sometimes weird, and they're not always connected easily. There may be some balance issues where some patches have a large population, others have a very small population, despite their size, but it has a lot more to do with connectivity. Finally, there's the patchy population, where basically it's all the patches are occupied, and there's movement between all of them, and usually they're all connected in some way, shape, or form. They're just happen to be separated by the matrix. So they don't really blink on or off. There's always individuals in them, and there's always individuals moving from one to another. Okay. So all of this kind of works well, but it comes from there's a basis of the ability of understanding the ability of animals and species to find patches, and the rate at which they're able to do that, and the understanding of that rate all comes from basically island biogeography theory, MacArthur and Wilson. And why we care about that when we're managing metapopulations is because distance between patches matter. Distance between large patches and small patches matter, because generally, and this works for mainland to island, but it also works for metapopulations where you have large patches to small patches. You can think of the mainland as just a giant patch if you really want to. But really, it is the closer you are to a mainland and the larger the island, the more likely you are to be colonized. Smaller islands that are close to the mainland, because the size matters, the ability of species to find it as they're moving through the matrix, because it's smaller, it's harder to find. Therefore, you have slightly less probability of having animals or species colonize that island, even though it's the same distance as a larger island. That holds true as you move further away, and there's this kind of equilibrium point for many of these, where we can assume that not only species finding them, but actually the trend of species richness follows this, where close to the mainland, small islands, large islands follow similar trends. Okay. If you think about it, there's also this potential for bouncing off of islands, where you can have some small islands that are a little closer to the mainland than, say, a second island, and how that basically, the species richness that are there and the colonization rate. What we see are nearer islands still have more species richness. Far islands have slightly lower species richness, but because there's a leapfrog effect, you get a slightly higher species richness than if that small island was out there by itself. Same kind of holds true with larger and smaller, same distance, and so on. the big thing to take from this is remember that the more matrix animals have to go through, the harder it is for them to colonize. The further a island, a patch is from another patch, the less likely it is to be found. The larger the patch is, though, matters, because the larger it is, even though if it's farther, animals can find it easier. Not all patches are created equal. Okay. Some patches are really good for species and are what we call source populations, where they're constantly growing and reproducing. They may have less predators or better cover, and therefore they provide a surplus of individuals that leave that patch and try to find a new patch. Other patches, they may be smaller, they may be lower quality habitat. They may actually be a net negative, where animals go in there, they try to reproduce, try to survive, but they actually, because of the habitat quality or whatever else is going on, don't survive and don't reproduce a net positive. And they're what we call sinks. So we have sources that are producing a net positive and generally are colonizing other areas, where we have sinks that are kind of being colonized, but not necessarily producing more animals than are colonizing, and therefore it's where animals go to die. We would call that, a good way to think about this is a lot of times backyards or small habitat patches that we think are good quality. We may be creating enough of an allure for an animal to come to it, but because maybe the house has a cat, the predation risk is sky high relative to another area, and therefore you're actually causing animals to die in what could be a good quality habitat, just because you're providing a higher predation rate with cats. Make sense? Okay. Things to think about with patches and islands. Two things. Topography matters. How animals are able to navigate topography is big. You also can potentially have certain habitat features at the top of islands. So or top of mountains, we would call them habitat islands or sky islands, where that actual habitat type is kind of isolated by the fact of topography. So that creates issues for some species in terms of navigating and colonizing new habitats or connectivity between them. So in addition, the species richness and the amount of niches that are available due to topography can also change things. And we saw, the island size, reality being, if it's an island that has a lot of topography, you're actually potentially going to have a higher species richness than an island that's the same size, 2D, without that third dimensional height increase. All right. And there's a formula to kind of calculate the number of species on an island, or more importantly, how we use this formula is when we're doing biodiversity surveys. It's how do you figure out how many plots you need to identify how many species are in an area or in a habitat type. That's another application of this. So what ends up happening, though, is there's a direct relationship between the size of an island or the size of a plot, or how many plots you survey, and how many species are present. So as you get an area that increases, whether that's a larger island, as that area grows, your species richness, because of both space and niches that are available, increases. Same works with if you're surveying similar habitat, the number of plots you survey, so the area you're surveying increases, you're more than likely to find and detect more species as you survey that area. But eventually that levels off when you hit a certain point, right? So there's only so many species that can exist in a certain habitat type. And once you no longer are adding habitat or niches to that area, you're not going to find more species. So with the islands, you get to so big and you just don't have any more species. With the sampling plots, what we try to do is we actually try to figure out where that line is because that's where that levels off is the number of plots we need to sample to make sure we're getting a true biodiversity estimate of an area or a habitat type. Okay. All right. So managing landscape level and connectivity between patches, and also just bigger picture of conservation of habitat, right? As fragmentation continues, we're seeing changes in habitat to less hospitable for wildlife species. We try to set up refuges, reserves, preserve certain habitat areas. So, we have limited amount of conservation funding. How do we maximize that fund or maximize that habitat that we want to preserve, knowing that area matters, interior habitat matters, the amount of edge you have matters, connectivity is important. So there's this idea that came from Jarrett Diamond and Dan Simberloff of single large versus several small, and reality being it's kind of a thought of a trade-off that happens a lot of times where we have certain situations where you may be able to preserve a large chunk of a specific type of habitat, so the single large, but often that doesn't happen. However, you may have the ability to preserve the same amount of area just in smaller patches. But what is better? Well, it depends. But overall, if you look at what you have available, so usually one large habitat or two large habitats is better than many smaller ones because you're preserving more interior habitat. So the top of that picture there on the left is better than the right. And in general, everything that's on the left side of that picture when compared to the right is better. So as we move down to number 3 there, where you have 4 similar sized preserves, having them closer together is much more desired because it reduces the amount of matrix between the patches and therefore allows for a higher survival and more connectivity between the patches. Same when you go down to 4, it's all about that distance to connectivity. So the ones on the left there, all 3 of them are similarly distant from each other. However, the ones on the right, though they're connected, right? So the one on the left is connected to the middle, the one in the middle is connected to the one on the right, relatively closely. The one on the left and the one on the right are pretty far apart spatially. So there's a harder connection between the two. Whenever you can put corridors between them, though you may preserve less area in general for one patch, you have better connectivity. That's in a better design than, say, having 3 large patches. Number 5 there, that's what that's showing. And one that doesn't have as much edge versus one that's long and skinny that has a lot of edge. So preserving that interior habitat is better than having a lot of edge and potentially more space. That's what number 6 is showing. And a lot of that has to do with this idea of, even if you're, not even thinking of edge habitat versus interior habitat, but there's an activity level that occurs on the outside of refuges that is different than what happens in the inside. So buffering from impacts, whether that's humans or other activities, is important. And that's why that single circle with less edge allows more buffer from what's going on the outside. So basically you have this transition zone that gets to a buffer, which is in the outside of the core area, which is where the best preservation is happening. Shape, as I mentioned, matters. And when you think about it, understanding what kind of corridor or core you have present is important when you do management and preservation design. So the larger the core area with less impact, the better off you are. Now, why that's important is because we have to be a little bit more pragmatic as we approach refuge management, preservation, whether that's on a small scale or large scale. And a lot of times we're moving towards this idea of working landscapes, and that's because getting slightly better habitat in that transition zone may be something that makes a huge difference for many species long term. You may not have the best habitat, but you may have a good enough habitat that it's no longer a sink. It may be a net zero, but net zero is better than a sink. So the idea, though, is still that there needs to be some core area that's protected entirely. But you may be able to do some use of habitats on the outside that may help folks grab onto the idea of conservation. So you have that core area in the middle, but you then have maybe a buffer zone that has some trail use, some interaction between folks in that buffer and that core area, kinda. You may be able to observe some of the wildlife you're preserving in that core area, and that's to get really to get folks invested in that. This is important that it exists. And then finally, you get to the outer buffer zone where you may see more and more activity. Sometimes you may even have some housing there, but you're trying to encourage good management and good stewardship of that area regardless. And finally, then on the outside of that, you get into that urban development, agriculture, human use. So it's basically trying to get folks to buy into the idea that conservation matters, preservation matters, and having these things present in the landscape, whether it's a park or a national refuge, is important to help ecosystems exist and to help species that use those ecosystems to survive development as it occurs. So how that matters, and sometimes when we talk about that buffer zone, that use, the working lands, a lot of it, trying to make sure it's close to things like historic disturbance events. And this is where we get into, things like grazing, cattle grazing in grasslands, or logging and harvest in forested systems, right? So those disturbance events, how large they are, how frequent they were, matter. And if you understand them, then you can try to replicate them. And that replication, can be important when you start talking politics and use of resources and needing, to use resources for economic survival of some individuals. It matters, and so understanding how those happen and at what scale may give you a scientific methodology to try to reduce disturbance, keep ecosystems functioning at a certain level, hopefully a pretty good high level, while still allowing humans to use the landscape. So replicating forest fires is one that was used in the West, and it's one that's used in the East, looking at disturbance size, so how many fires occur on a regular basis, how large are those fires in acreage, and you can see that very few 5,000 plus acre fires occur, but there's quite a bit of smaller, sub 10 acre fires that would have destroyed or caused disturbance in the landscape and the forest. So if you start talking about logging and the need to log, well, you can do quite a bit of small stand logging and replicate disturbance in the forest. You can't really do a whole lot of 200 to 300 acre cuts in a forest and still not change the ecosystem function. That's kind of what you could take from that. The same kind of holds true with other resources, looking at number of lakes, number or linear usage of feet, in terms of rivers, corridors along those rivers. All of that, you can start taking things that matter in the ecosystem and try to quantify what's going on. This may play a role in terms of access to resources, whether or not folks are trying to disrupt the number of ponds that are present, getting rid of beaver dams that are there, those kind of things. Other considerations, understanding the soil that's going on, the soil size of where contiguity in the terms of types of soil is important. because that's going to, soil works its way up to the plants and so on. So these are kind of examples of how you need to understand the system, and things vary across locations. But all of these need to go into planning for how you may use a resource and finding that working lands component. Now that, real world application of this has happened, where especially with the spotted owl issue in the Pacific Northwest, where old growth forest was really important to spotted owls. So how logging is also the major industry in the area of where the spotted owls are in Oregon, and trying to figure out a way to balance between the two to conserve the species while also not driving the entire community to bankruptcy and loss of jobs. And to some level it happened pretty hard. A lot of folks lost their job because they weren't cutting at the rate that they were cutting at. Now, was that rate sustainable? Probably not. So they kind of knocked it back, but looking at old growth trees where they're past their prime, in terms of the rotation, was not something the folks there could buy into that hard. So what they had to do was find a way of balancing, those core areas of old growth with still having a working lands idea, and trying to, maybe harvest a few of the old growth stands, but make sure they're being replaced at some level. And a lot of that, was based on looking at the forest size, historical forest size distributions, the stand size distributions, and how quickly do they replace themselves. And the thought was that small stands of old growth forests are still predominant to what was, there in turn, previously. However, what they were trying to do was basically increase the number of small sub 50-ish hectare old growth stands, which would allow for more harvest of the other stands. If you're only saving some smaller stands to meet your management goals needed for the species, then there's a lot of other stands present that can be harvested and allow the economics of the region to keep chugging on. The solution, though, which he proposed, was trying to have the number of cuts correspond to a certain size. Okay, so you have some cuts that are very large, that are less frequent than a lot of the smaller cuts. Now, how that works in the forest industry is larger cuts generally are, in terms of efficiency, easier to get logs out of the woods. If you have to do a lot of small stands, small cuts, small area cuts, you have a lot more problems moving those logs out of the woods because there's more logistics involved. But their solution was to do that. Basically, you have a lot of small cuts, a few larger ones, but total area being cut is going to be pretty similar across the landscape. That was kind of the solution. The logging industry, it allowed them to keep going on, but they were not making near the amount of money. And you still see bumper stickers out there that are things like "nothing tastes better than pan fried spotted owl," stuff like that. They're not super thrilled about it. But in terms of politics, it was a solution that allowed them to kind of keep functioning. It didn't shut the entire economy down, but it definitely reduced it. Other case studies that you should be aware of, one locally. So black bears in Kentucky, in terms of their recovery and patch management, in terms of landscape. What we see are areas in Southeast Kentucky, Big South Fork recreation area. You have the Daniel Boone National Forest. All of these areas allowed basically a small population of black bears to navigate a landscape that they were basically extirpated from But as they've been colonizing, they've been expanding. The connectivity of the two areas allows that population to basically move pretty freely, and it has now, shown that it's somewhat connected even to the larger population over towards Black Mountain. The bear population is growing, about 8 to 12 bears a year. So we're somewhere around 300 bears in Kentucky as of 3 years ago. So we're probably somewhere around getting close to 340 to 350 bears now in Kentucky. But it works because the Daniel Boone and the amount of forested land that exists in Southeast Kentucky allows those bears to navigate the landscape without getting hit by cars as frequently, which is the #1 killer of bears in our state. We lose about 40 to 50 bears to vehicle collisions each year. So having those travel corridors where they can avoid roads is really important. Other things that were proposed that never came to existence, but it gives you a good example of the thought that goes into to trying to come up with these big management goals. There was a push at one point in time to try to bring wolves back to the Adirondacks in New York, with the hope that you could basically make a connection to Maine and to Canada, where the wolf population exists, and try to get them so that they can either naturally come down to the Adirondacks, where it was believed that they would be able to exist. And this idea that the timber wolf was going to be able to kind of, if you created a area where you were going to try to bring them back, could they eventually make it down to colonize more of their natural pre-European range? So there was a lot of thought looking at various national parks and how then do you maybe expand on conservation practices and create basically a corridor that runs from the proposed recovery plan area down all the way to the Adirondacks. That was the thought process. Unfortunately, we know that there's no wolves in Maine, and there's definitely no wolves in New York. It all fell through. Politics came in, and most of the wolf restoration happened in the upper Midwest instead. That's the way it happened. So, all right. So that's kind of a rough go through in terms of landscape management. The big picture here is you have to take a step away from the stand that you're managing, whether it's forest, grasslands, the property you're looking at, and kind of peer at what's going on in your neighbors. Get on Google Earth, think aerial view, look down at multiple scales, and try to understand if you need to be creating certain habitat types to one extent on the property because other types of resources are being met on neighboring properties. All right. Questions associated with that? Anybody? You're all still there, quiet. Ben, do you have a question? Or is that just, yep.
No.
All right, your hand imprints up there. That's why I was kind of thought you may have had one. All right, everyone's good. Okay, so those that are going to come to lab, please show up at 12:30. Check in with Kate. I'm gonna finish up with this and then let my dog out and come into campus. So I'll see you at lab. I thought I saw and Scott on here. He may not be on here anymore. Anyway, you all have a great Thanksgiving. If I don't see you, enjoy your time off. And we only have 2 lectures left. So class is wrapping up pretty soon here. Okay. Take care. Don't eat too much turkey or whatever else you all traditionally eat on the holiday.
Thank you.
Thank you.